All right. Hi, Nicholas here. I'm here to introduce the software as a service that we built for the cloud computing course. Um, so I'm just going to give a brief description of the application before we do any walkthrough, right? So the Rich Cloud Messaging Service, right? RCMS is a software as a service public cloud solution that will allow developers to focus more on the experience of the application and less on the nuisance of building and managing Internet Protocol messaging stack. It is an application service which provides a generic messaging service that can be configured on an application basis. The RCMS platform aims to harness the power of the cloud and presents it to the developer as a scalable and reliable full-stack messaging service that is easy to use, configure, connect, and port into new and existing applications. Right? RCMS would provide handling of all application message routing, will guarantee successful delivery of all messages, provide notification and error handling protocols, provide automatic service management and development, provide analytics and management tools for developers, expose developers that are easy to use and implement messaging API for app integration. All right. The RCMS service consists of two components, right? The first vital component is the online management portal, OMP, right? So the OMP allows developers to log in to the service and define their applications and its requirements. The OMP allows the developers to manage the applications they have and yeah, that they have by viewing usage statistics, updating configurations, and removing applications from production. Right. The second part um, of RCMS is the core messaging system that consists of messenger service manager of the messenger service manager, sorry, and the messenger service instances, right? So the MSN messenger service manager is responsible for the deployment and maintenance of all applications developed by the developers. The application deployed by developers are managed as messenger instances, right? So the MSN is capable of automatically stopping and starting these message intervention of any human operator. Sorry. Um, it is also capable of clustering messaging instances for scalability and restarting any problematic messenger instances to ensure high availability. So now you have uh, a slight background to what the RCMS is. So let's just dive into it here and see how it does what I explained, right? See here, you could log on to, access the online management portal via rcms-cloud.purcoapp.com/index.html. All right, let's register. All right, so Nick Sing Nick at mail.com, password. All right, so we registered. Now redirected to the login page. Let's log in. Nick at mail.com. Right, save password. So we are here on the home page, right? You can see we have we're on the applications menu where you could create applications. Currently have no applications here, right? You could view the packages, which describes each type of application you could create and how much it would cost and the constraints, right? So we have free, basic, premium, and enterprise, right? So first things first, right? The 5 essential characteristics of cloud computing, right? So the first one that we're going to cover is on-demand self-service, right? So basically, users are able to provision cloud computing resources without requiring human interaction, mostly done through a web-based self-service portal, which is what we are on right now, right? So on-demand means, right, we could create the app, right? Give it a name. So we're going to give it my first app, right? What type of application it is? It's a free application, meaning that, well, based on the free. So if we want to look at what free components, what the free offers, right? 100,000 transactions per day, broadcast chat, 20 concurrent users, no chat rooms, no private chats, no extras, right? And here, added incoming transaction fee, meaning that we cross the 100,000 free transactions per day, and the added outgoing transmission fee, right? So we could see 0.002 cents, right, per kilobyte, and 0.005 cents per kilobyte outgoing, right? So this is if we exceed the 100,000 per day. So let's go back, right? We created a free. Here's the location, North Central US. Let's create it, right? So here we just provisioned the cloud computing resources, which is free, right? And so yeah, this is how we cover the on-demand. Just some particulars here. The application type is free. Here's the name. The application ID is what Chilton would be showing you how we'd be using that a little later on. The application ID and the port, and the cost here, of course, is 0, right? So just to talk a little bit about broad network access. So the application here is hosted online. Anyone can access it via mobile or desktop web browsing, right? As well as the core messaging service, right, which Chilton would explain a little later on, is also accessible via any network once you have a Wi-Fi network or a data plan, right? So let's just look at, when we click on the application here, we would see some statistics. Of course, there shouldn't be any because we now created the application, right? Yeah, so here we just seen packets by bytes, and the, well, here should be the time, but of course, well, later on we would actually come back here and you would see some stuff, right? Here's the settings. So here we would cover rapid elasticity, sorry, right? So resources are provisioned and released on demand and or automated based on triggers or parameters. This would ensure that the application will have exactly the capacity it needs at any point in time. So right now we have a free application, right? And well, here you can see it provides 100,000 free transactions per day, right? But if you look at the cost here, it's 0.02 cents incoming and 0.05 cents outgoing, right? So if we want to change, well, let's look again. Right, if we wanted to go at the basic, notice here the incoming transmission fee, sorry, is less, and same for outgoing, as well as there is an increase in the number of paid transaction in this case, right? And the cost here is 10 US per month, right? Premium, same, well, cost is more money, more transactions, less cost, and enterprise, right? So back here, if the user wanted, right, you know, the free wasn't cutting it and the cost going up too much, we could change it to a premium package, right? Well, we didn't implement actually enter in the monies, right? But here we just demonstrated that it could be done. Well, how it could be done if we implemented it, right? And so the user wanted more, they got more, right? And if they wanted less, we just change it back. So Chilton would actually show you how this is being done in the backend relating to the core messaging service, right? So that's rapid elasticity. I would mention about the measurement and the resource pooling a little later on. Alright, so now I would hand you over to Chilton, right, which would talk about the core messaging service. Yeah, Chilton, you take it away.
Talk about core messaging service. If you hear me clearly, right?
Yeah, here, you're good.
Alright, hey, this is Chosen here. Here to talk to you about the core messaging service, which is comprised of the MSN, which is the Message Service Manager, and the MSI, which are the Message Service Instances. Oh, wait, hold on. Wait, you share screen?
Go. No, sorry.
Oh, okay.
Sorry about that, folks. Actually, yeah, I am sharing your screen.
Oh, oh, okay. Oh, cool. Well, I had it on the wrong thing, I guess. Okay, so, hey, Owen, this is Chosen here. I have to talk to you about the core messaging service, um, comprised of the message service manager and the message service instances. Um, I'll start with the message service manager, which is basically responsible for the on-demand creation of um, and deployment of the message service instances. Um, the message service manager, along with all the message instances, are actually stored on Google Cloud Infrastructure, the Google Compute Engine. This makes our service accessible from pretty much any device, as it uses a simple HTTP protocol for connection and access. Yeah. So when a user creates an application on the web portal, right, a message is sent from the web portal server to the MSF, who will then fulfill the request by creating a new message service instance um, as specified by the user in the configuration on the application console. um, how the MSM works here is an example of the actual MSM script. Is pretty simple stuff. A simple push request is made, and this then triggers a query to the database server to see what the configurations are. Um, then it will update either a running instance package, because the server actually keeps a log of all running instances, and it either update or create a new instance. Um, it will manage instances by freeing and creating or just creating new instances. Um, the the instances, when they're created, are passed with them um, the the port that it should run on, the key, the application key that it should use, and the basic package, what type of services is running, whether it's basic, premium, enterprise, etc. Um, the key is necessary to provide um, the resource pooling, right? Key is used extensively by the MSIs to help um, partition its data from the data of other MSIs. So MSI from one application doesn't interact data with that from MSI from another application. Um, since the keys, since they don't know each other's keys, and one of Microsoft Azure's um, features slash requirements is that you must specify the partition key you want to pull the data from. So um, having the application key, which is unique to each application, is very important to the resource pooling aspect. Once the application the MSI is launched, right? This script here is really what is the core of one of the MSIs. This one is for a more basic package as it requires authentication within it. Again, pretty simple stuff. Basically, what the script does is it negotiates basically authenticating the user, creating and notifying subscribers, etc. And it basically defines the protocol that should be implemented by the client. It defines protocol on the server that the client will be using to access the service. Right? Also created a data store object which passes the auth key. Um, like I said, mentioned earlier, the auth key is used to partition the data. So it's very important that the data store object or the data store manager, the object that manages the data store, knows what this auth key is. So it is given that parameter there. And um, our our application is started on the passport. So, I'll go into a quick demonstration of what all this means. Um, let me just bring up the app here. Refresh the page. Good. Alright, so we see here that Nick um, created there are two listing MSIs um, currently running. One on port 403, one on port 402, and I believe the latest one was the one Nick just created on port 404. It seems he changed a few parameters or configurations within it, and it restarted a couple times. Nick, how about you change something, like change it from basic to enterprise or something?
Change it to enterprise, is it?
Yeah, from basic to enterprise, anything. Let's just see what this thing fires on, if it does anything at all.
Alright, yeah. It's on free right now, so enterprise.
Yeah. So there you go. You actually see started the instance. It's on port 404, and now it would have restarted the instance to run on that enterprise um, um, usage or profile, sorry. Um, not all the profiles have been implemented at this point in time. Currently, we're just using the basic profile, where you have basic authentication and most of the features are already built in. Um, so, from a client perspective, all they need to do to connect to the server is to know the URL of the server as well as the port they want to be on. They want to connect to. The URL will be the Google URL, and the port will be 4004. You connected, and a nice little message saying that the site has been connected and on server wants us to authenticate with it. Now we're making a new application, so they're not going to have any users. So what I'm going to do is quickly create one. So now successfully created my new account into his also authenticate the account. So I'm not connected to the network, right? I'm also going to ask Nick to create one. Like, could you create one and
Yeah.
you have the cards open there?
So
Yeah,
um
just go back to your screen and
so
see.
connect first, right?
Yeah, you connect with us. Tell my screen, you can see um this thing just populate with data.
Alright, so I'm gonna create an account, you say?
Yeah, let's create an account.
Mail.com email. Oh, shit. So I'm gonna create my phone now.
Alright, create. So Nick just created an account with an identity nick@mail.com. So what I'm going to do now is I'm going to subscribe to that identity. Right? So I'll subscribe and can I subscribe to subscribe to Nick at Mail. What this will do is when Nick disconnects and reconnects the next time, I will be notified that he he's online. But I also get his information. So if I want to store his information on my device, so I could see him like a friend list or something, I could do that. So like could you refresh the page, refresh the application? Yeah.
Refresh and connect.
Yeah, and connect transacted, and then just log in with the previous thing. Yeah. So
Right.
you got the disconnect event file right disconnected, but he just re-authenticated, and now he's there he is. He logged in and he notified me identity makermail.com. So now I know he's online. And to chat with Nick, what I will do is I'll just paste this into the sent to currently we didn't really build anything too fancy. So whatever is in this, whatever identity is here in this field, this client will try to send to the identity. So I'll say hi to him, and we
Hi.
should get
So
something there. And
just switching quickly. You can see hi here. Let me just say sup. So switch back to Chilton. Should see sup.
yeah, and that's pretty much it. Right now we have full messaging going. I could talk to him and he could talk back to me. He just send something my way. Pretty much can just send give it and so nah, none of that. Yeah, so need to censor this thing. Yes. So that's basically an example of clients working there. Right. So what I was able to show you here was the on-demand nature of the service by automatically creating and deploying new MSIs as they are created, automatically reconfiguring them without having um, anyone to come in and do anything. There's no downtime. It's almost instant. Yeah. Also, look at the resource pooling efforts we made on our end of the server by keeping um, user information defined within the scope of an application. Uh, we talked about the broad access you get because basically an internet web service built on HTTP and TCP. It's pretty easy to build new new libraries or clients that are connected. Yeah.
All right.
So I'm connect so we could talk to you more about the measurability. Oh, that reminds me. There's a lot of measurability on this app. Within the worker thread, um, if you look closely, you can find a spot possibly where oh no, it wasn't here. It would actually be in the data store, right? Ad statistics, the data store ad statistics, right? So you see here when we send a message, we actually add statistics to data store. What the the type of what is ingoing or outgoing length of the message, the event that was fired as well, right? You see here we do ingoing length of the string, the event was a subscribe event. Um, and you could pretty much just using this to track and partition tracking these messages according to application. And got a lot of information, a lot of metrics that can be used in measuring the service, uh, essentially billing and such. See, I have actually next week to talk to you more about the client side and billing data.
All right. So basically with measurability, right? Measured service resource usage are monitored, reported, right? Transparently based on utilization, right? Ensure pay for use. So let's just go back to the app dashboard. So here we could see the cost, right? 0.00318, right? So what does that mean? Let's see. See here, if you look at it, so this is packets in bytes, right? And these are the times that they were there. So notice we barely make a kilobyte, right? This is packets, incoming packets. Here is outgoing packets, right? And here is the incoming packets versus the outgoing packets. Sorry. So you can just see the sizes of packets, so you would know if the messaging, if someone chats a lot, or sorry, if the person, either or person, you would know who chats more, I guess. All right. Yeah, so that's how we could measure the service here, see the amount of packets, and we could view the current cost of the application. Right. One other thing, right? Just to mention about the resource pooling again, Chilton mentioned it. Based on the applications, but what we also did is each client is partitioned in a user partition in a user table, sorry, and we have their email, so we could just bring up the code here. So yeah, the email is what their row key is, right? And based on that email, when a user creates an application, they create a partition using that email, right? And the application ID that we generated is what would be the row key. So based on each user's application, right, we would have a partition storing each application, right? With the resource pooling, this would work for for all users, sorry, and basically they're using the same physical storage, but none of the apps would ever interact with each other. So this basically just describes the resource pooling. So just to reiterate, we covered the 5 characteristics of cloud, right? The on-demand, the broad network access, the resource pooling, the rapid elasticity, and measured service. Um, so I think that's about it, Chilton. Did we forget anything?
Nope, I don't think so. If he has any questions, I suppose you can email us.
Yeah, yeah. Any questions? Email or even a hangout, right?
That'd be cool.
All right. Well, hope we get some good grades.
Thanks for listening.
Yeah.
Yeah.
Laters.